Vishnu, and I'll be covering the Junior Advanced class for our Guru Math Circle. Welcome to Session 2. This session is about the place value system. The major topics that we'll be covering today are the place value system, addition, subtraction, multiplication, and division, rounding off, and estimating. 2.1 Place value system. So right here you see the place value chart, and in this chart we've put the number 124. So what this chart allows us to do is basically categorize numbers. Now, this chart really revolves around the decimal point. To the left of it, there are the ones, tens, and hundreds onward. And to the right of it, there's the tens, hundreds, and thousands also going on in this direction. Now, what's so special about this place value chart is that it allows us to define the number. And what I mean by this is that there's a 1 in the hundreds place. 100. There is a 2 in the tens place. 2 tens. There is a 4 in the ones place. 4 ones. Now, 1 times 100 is 100. 2 times 10 is 20. 4 times 1 is 4. This arithmetic adds up to 124. As you can see, what we started off with is exactly what we end with. This chart really allows us to show each one of the place values, or places where digits can go, and allows us to visualize in this expanded notation how the number is put together. 2.2 Addition. So most of you probably know already how to add, but something that might be new to you pertaining to addition would be the concept of carrying over. Now, in some scenarios, you might get a problem like this: 34 plus 66. Now, your first instinct would be to do what we would call the one side, 4 plus 6. But oh wait, 4 plus 6 is 10. Now, you can't fit 2 digits into one placeholder, so you hit up a bit of a problem. Now, this is where carrying over comes in. And to explain this, I'm going to resort back to the place value system that I taught you in 2.1. Now, let's take, for example, a number, a 3-digit number, and we want to have 10 ones. Now, once again, we can't have a 2-digit number in a 1-digit slot. So we need to find a way to change this. Now, what I have right here is 10 ones is the same thing as 110. So what you can do is take these 10 ones over here and rewrite them like this. The 10 ones become 110 and get added to the 10 section. The equation, or the number, is still the same number, except now it actually fits into the place value system. Likewise here, instead of having the ones having 10, we have tens having 10. Now, 10 tens is the same thing as 100. So because of this, once again, we can say that 100, 10 tens, and 2 ones is the same thing as 200, 0 tens, and 2 ones, because we took the 10 tens here, and 10 tens is 100, so we added 100 here. Now, when we use this for addition, we have 10 ones. And once again, like here, since we have 10 ones, we can add the 10 ones, or 10, to the 10 section. So what that does here is, instead of putting 10 here, you're going to put a 0. So you have 10, you're going to take the 0 and put it here. But the 1, you take here, because the 10 tens made the 10 ones made 110, and now that you can add a 1 here, that balances out, making 100. Now, there are a couple of practice problems in that section, and I also think of the previous section. As usual, you may solve them and leave them in the comments below, and I will double check them for you. 2.3 Subtraction. So, most of you probably already know how to subtract, but once again, we're going to go over something you may not know, which is carrying over. So, we have this problem right here, 48 minus 39. Right when you start the problem, you notice that there's a bit of a conundrum. You can't subtract the 8 from the 9 because the 8 is smaller than the 9. Now, how we're going to solve this is we're going to do the opposite of what we did for the addition. Now, I'm once again going to go back to the place values system. And previously for the addition, what we did is if we had a double-digit number for any place value, we were able to take that number and make it the next place value. Now, what we're going to do is the exact opposite of that. Now, we need to make this one section number a little bit bigger so that you can subtract it. So what we're going to do is we can take the number from the previous section and we can take 10 from that and put it in here. How we're going to do that is, if we want to make this one's a 10, 1, we take 1 10 from here, so that makes the 1 10 0, and we add the 10 here, 10 1s. Likewise, over here, we need the 8 to be a lot bigger, so we take a 10 from the 10 section, we get a 3 here, we add that 10 here, 10 plus 8 is 18. 18 minus 9 is not possible with 9. And 3 minus 3 is 0. So your answer in the end is number 9. One thing I do want to point out though is on the lecture notes, it does say, both for addition and subtraction, that you solve them from left to right. That is wrong. You have to solve them from right to left. Once again, solving subtraction and addition, right to left. 2.4, multiplication. So you guys probably know already how to multiply single digit numbers, but this one's going to be about double digit numbers. So right here we have 68 times 12. That might be a very confusing color coordination right there, but I'll explain it right now. Now, what this is trying to say at least, is that you have to do 68 times 2 first. That's why it's in an orange bubble, whatever you want to call it. And then next to it you have 68 times 1, which is in a purple bubble. So if we were going to do this, we have to do the orange one first. Now if you do the orange one first, you have to do 8 times 2, 6. 16 actually, but since it's 16 and you can only fit one digit in a place value, you take that extra 1 and you throw it into this 6 over here. So you have a 1 right here. 6 times 2 is 12, and the extra 1 from the 16 is over there, so you get 136. Remember, any carryovers always are added in multiplication. Next, this is the most common mistake that you see with multiplication. Once you finish your first bubble of this sort, before you start your next multiplication, you need to add a 0 below the units digit of the last number you wrote. Then must start the next one. And the reason is because, if you see here, the 1 in this 12, and currently in the purple, is in the tens digit. Therefore, you need to have the product of this 1, or the entire number, from the tens place and onward. And the same is to say, if there was a hundreds number, it would move from the hundreds and onwards. So, over here, 1 times 8 is 8, this is quite simple, and 6 times 1 is 6. So now that you have your 2 bubbles, you just have to add the rest of the numbers, and that we already covered. So this comes out to a grand total of 816. 2.5, division. So you guys probably once again know how to divide. I'm just going to go over how to divide. Right here is the usual standard positioning of division. You have your dividend inside your division sign, divisor on the outside, or the thing that divides up the dividend, and your answer is known as a quotient, which goes on the top. So right here we have a problem. So first of all, you would take your divisor and you would check if it would go into the first number of your dividend. In this case, it does not. So the next step to do is to check if your divisor goes into both of these numbers, which it does. Not perfectly, but it does. Now, 4 goes into 31 7 times. Now, if you're not sure about this, please do check the table that is given in the lecture notes. That will help you with all the multiplication and so on. 7 times 4 being 38. Now, 28, my bad. And when you subtract this, you get 3. So your answer turns out to be 7 remainder 3. Once again, I'm just going over. You try to get your division to work, divisor with the first digit, second digit, and so on until you solve the problem. Most problems that you may get may not always have solid one number solutions. So if there's a remainder or a number that is too small to be divided by the divisor, you leave that outside as a remainder. Rounding off, 2.5. So when you're told to round off, you usually get a number like so, and are told to round it off to a certain place value. In this case, I'm going to tell you to round this to the nearest tenth. Now, it's important to note that there is tenth and there is tenths. Both of these are place values. I know they named it very, very confusingly, and why? So, tenth refers to the left side, second, from the left side of the decimal point, second place value, and tenth is the first one to the right. So I think it's very important that you don't get these two confused. But that's besides the point. Alright, so if we are going to round this to the nearest tenth, this number would become 250. How I got that is I took the ones digit, and if it was 5 or above, I would have wrote this as 260 because it's closer to 260 than it is to 250. But since it's a 4, I chose 250 because it's closer to 250 than it is to 260. And that's all rounding is. Now, for example, if we have a slightly bigger number, 1276, and we want to round this to the nearest 1,000, we would take the value before the thousands place, and we would use that to judge our rounding. Now, since it's less than 5, we would round down, or closer to 1,000. So this becomes 1,000. 2.7, estimating. So in this section, we're going to cover how to get what we call an approximate answer, or a really close answer to the real answer. That's a lot easier to get than solving for the actual answer, and it's just about useful. So we have this expression right here, and what you would notice is this number is 998, really close to 1,000. So what we're going to do is we're going to do this calculation as if it were 1,000. So working with a number that has a 0 at the end, or has as many zeros at the end and in the number as possible, is usually very, very easy to calculate. And because of that, we can estimate answers by rounding, as in the previous chapter, to the nearest place value that you think is appropriate, and then doing the calculation. So this we can right off the bat tell, 1779, when you're adding these two together. That's how easy it is to estimate. And one more thing that we can do here is, after estimating, if we know how much we added or subtracted to a number to make it a helpful number like 1,000, we can re-subtract it or re-add that back to get the exact answer. So right here, this may be our approximate answer. When you're writing approximate answers, you should write your equal to sign, something like this, a little slanty. If you want the exact answer, just subtract that back out, 1797. Alright, so that concludes session 2 for Junior Advanced, Agora Math Circle. If you liked the video, give it a thumbs up. If you really liked it, subscribe for more videos like this, and thank you very much. Any suggestions, comments, anything of that sort, please leave it in the comments below. I also do check to see that people do the practice problems if they're left in the comments, and I think one person did it after last class. I do give the correct answers afterward, and thank you.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org, or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!